Welcome to radar system course. Today we see that a tracking radar. So in a tracking radar, we need to identify that where is the target from the given okay from your antenna. So this one is about your antenna, and we are supposed to say that this one is about a target. So our aim is about to find out the location of the target. So where is the target? Okay. So now the target is present at what particular place, so we need to locate that particular target. In that case, we say it's supposed to be a signal, and we are receiving the echo signal from the target. And then from this, if it is a moving target, so then a moving target has some particular speed. So we need to find out what will be the range. Okay, we need to know about what will be the range, and we need to know about what will be the location. Location means position. Okay, so we can say that none other way we can talk about that it is nothing but the position of that particular target. Okay, so now we say that most of the time that the target is uh, having a position. Okay, so that position is nothing but what somewhere in a space. So in that case, we need to know about what will be the position in terms of azimuth and elevation. So azimuth and elevation means what? From the ground surface, if you say that, okay, so we have, okay, so this is nothing but a ground surface now, I'm supposed to say. So this, from this particular ground surface, what will be the position in terms of the angle? So azimuth means what? We say that this is nothing but the angle, and this is the ground. So we can say that this one is about your azimuth here. Okay, so elevation is nothing but what? This much is about the angle at what particular elevation with this with makes with a theta. So we need to know about that elevation angle as well as the azimuth there. Okay, so that is about the position. So mostly, if you see that the position of the target, we need we find out here. Okay, so why this required? Because sometimes we require this one to identify the enemy enemy missiles, or we need to identify that enemy fire jets. Okay, so and then we need to target those things. So that is nothing but a part of the navigation, or we need, that is nothing but a part of the surveillance. And same is to be used uh, in another conditions also. Okay, suppose we say that we need to identify that what about the missile position or the enemy okay, or suppose if we have any war is going on. So in that case, we need to identify what is the position of the given particular target. So in that case, we need to track the particular object. So for a tracking, we need a antenna, specific antenna for this. Okay. So in that case, we say that what will be the radiation pattern of an antenna? Okay. And through that radiation pattern, we say that what will be the area covered by this using this particular points from the beam width. So this is about the area covered by the antenna. So within this particular radius, okay, if I rotate a antenna now, so that antenna when it is rotating, so it is about the at a center point. We say that this one is about antenna. So if antenna is rotating, in that case this much will be the area covered by the antenna. Means within this particular area, if supposed to be any target is present, so that target can be identified by the antenna. So, so we need a and that radar which has a pencil beam radiation pattern. Okay, so pencil beam radiation pattern means what? It is about a very small beam width. Okay, it has a very small beam width. That is about a pencil beam like pattern, and that radar is used to detect. Okay, or we can say that that pencil beam can detect the target, and from this particular pencil beam we can say that it is useful for detecting the target, and it will provide what will be the location in terms of what the angle there. Okay, that will be the in terms of angle we are getting what a azimuth, and elevation. So we can find out what will be the angle in terms of the azimuth and the elevation there, means location of a target, and in the location of a target we should know that what will be the value of a azimuth and a elevation there, and then it will determine the direction. Okay, so in which particular position that antenna is to be keep there, okay, or we need to move the antenna there, or we can say that we need to maintain the target within this particular beam. Suppose I am saying that, okay, I say that this is about the area coverage here and antenna is here now. Suppose target is present, okay, so we say that the target is, so we need to provide the antenna position in the given direction. So we need to locate the target first, okay, at the given particular place the target is present, and then we need to move the position of the antenna beam toward this particular target. So means we need to maintain, okay, we need to maintain the target within the given beam, means we can say that from this antenna the radiation pattern will be likewise. Okay, so we need to maintain throughout. If supposed to be this target is moving, it's supposed in this direction, so that beam is to be rotated. So once we lock this particular position and a motion of this particular moving target, so then antenna is to be rotated. Okay, so antenna is to be rotated as per the motion of this particular movement. If that target is moving within this particular region, then we can move this particular antenna. So we have here at this particular bottom of this antenna, okay, so there are some motors to be there, and that motors are used to vary, or motor is used to rotate that antenna in a given particular direction. So we can find out what will be the position of the a target there. Okay, so we need to know about the location. Now then we need to know about the measurement in terms of what? Measurement of angle. For a measurement of angle, while tracking, we need to find out what will be the antenna pattern we are getting, okay, from the given particular target. So for example, I say that, so I have initially I am getting, okay, so there are the two ways to draw a radiation pattern of an antenna. Okay, so we can say that a radiation pattern of an antenna can be drawn in terms of what? A polar one, or we can say that we can with uniform. Okay, so in that case, if we can say that it is about a polar, so we will get that in terms of a gain or in terms of a output there. Or another way we have the okay uniform, okay, pattern. So we can say that we need to use that a amplitude there, or what will be the value, okay, whatever the received value there. Okay, so just like we have seen that XY patterns and all XY graph. So similarly, we are getting that amplitude pattern. So mostly, if you see that if people are using a polar pattern to identify that what about the radiation. So in that case, we can say that a radiation pattern we are getting by this way. Okay, so that we have observed through the polar pattern. So in that case, we say that these are nothing but the angle of a degrees and all. So and then we are getting the radiation pattern for this, and these are nothing but the what we can say, okay, what will be the amplitude, or what we can say that gain of this pattern. So we can find out, okay, the pattern first of a target from a given particular target, while determining the target there or locating the target there. So we can say that a radiation pattern, for example, I say that a amplitude pattern here, we are getting initially for a given particular target, this one will be the radiation pattern, and then we can say that we are getting the radiation pattern likewise. So in that case, what we are saying, our target, because target is present in the forward direction, Okay, so I say that initially this pattern will be A, suppose I am saying. So at that point the target is here. Then we rotate the antenna, so then we are getting the pattern like that. So in that case, what we are getting? So we are, our target may be here. Okay, so where will be our target? So because we are rotating the antenna, so in that case we say that a target will be supposed to be here now. Okay, this one is about your a target now. But what about the bore site of antenna? Because we are getting a radiation pattern 1, radiation pattern 2. So in that case we can say that at a center of this one, this is nothing but what? A bore site. Okay, so we can say that this one is about a bore site of an antenna. So this one is target. So from the bore site to the target, if you find out the angle, so that angle is called as a squint angle. So means two beams we have. These are nothing but the two radiation pattern of a antenna, or two beams we say that beams are squinted by an angle. That angle is depending upon that bore site and a target. Okay. And in another case, I suppose to say that we have a radiation pattern of a antenna is likewise now, and this one is nothing but what? A beam axis. This one is about a beam axis, and I supposed to want to move this beam here, or I wanted to rotate the beam. Okay, so in that case, so what will be the rotation axis? Supposed to be this one is the rotation axis, and this one is about the beam axis. So angle between this beam axis and this rotation axis is nothing but a squint angle. Okay. So in another way, we are getting the beam pattern this way, or we are getting the beam pattern by this way, because we are rotating the antenna to identify what about the location of a target, and because of the target locations we are getting the two different beams. Okay, so that this way we can say that a com communication, or we can say that position of the target is to be identified through this antenna pattern. Now, now in this case, what happened? So this one is about a bore site. Okay, bore site of a antenna. So what about the red that target bore site? Okay, so in that case, the bore site is like because target is in this direction, antenna bore site. So we need to match the bore site as well as the a target direction. So once that bore site and a target direction match, so we can identify, or we need to lock the given particular position here. So in that case, that angle between this target and this particular bore site is to be a zero there. So we can locate a target easily. So how we can say that? So we can obtain through this way. Okay, so we are getting the pattern from this first antenna. Okay, so now we should get the pattern from the another antenna, like about another pattern. So now where is our bore site here and the target? So now at this particular point, here the angle is same. Okay, so what we can say that we have detected that this is nothing but a theta 0, this is about a theta t. So in that case, angle what? A theta 0 is equal to a theta t. Okay, so in that case, this is nothing but what? A bore site we have, as well as what we can say that a target direction. Okay, this one, both. This one is about a bore site as well as a target direction. So we can say that this belongs to what? A theta 0 and a theta t here. So through this, we can find out this angle. So means your angle is overlapping, means your radiation pattern is overlapping at this particular point. But here in the case, if you consider that amplitude of this radiation pattern is here, okay, from this and from this here. Okay, so we can say that there is a differentiation. Okay, these are the two patterns. But if you consider that in the case of a bore site, so this way and this way. Okay, so your radiation pattern is overlapping toward the target direction. So now we need to find out from this what will be the position of a this antenna beam. Okay, so in which particular line. So we need to find out what will be the a crossover point. So now this one is about a crossover point or crossover amplitude. Now this is belongs to amplitude. So at this particular point, okay, so this beam, two beams are here. these two beams are crossing at this particular point. So crossover point of this particular beam, that we say that it is nothing but a bore side, and this one is about a target direction. So when it will matches, okay, so angle between this. So in that case, split angle will be a 0 there. Okay. So now, so through that we can find out what will be the target position. So this theta 0 is to be theta t. Okay, always. So that we can able to identify that a target. So we can find out the target, and then we can determine what will be the coordinate of a target from this ground position there. Once we got the coordinate there, so we can do the measurement of a, or we can do the identification or position location or location finding of the given particular target. So there are various ways of finding this angle there. Okay, so that we can use a beam, various technique to locate the given particular target. So we can consider right now, instead of that angle tracking, we will go for the tracking in which we use a beam. Okay, so in that case we say that another topic, or we can say that a new way of tracking the or identifying the target with respect to their angular information. Okay, so we can say that a monopoles tracking radar. Okay, this one is called as a monopoles tracking radar. So in this case, we can find out what will be the angular location of a target by comparing the signals received from the various beams. Okay, we can say that we are just getting a echo signal. Okay, that through that echo signal we can find out the what will be the location of a target. Okay, what will be the location of a target from the echo signal. So how to do the measurement or how to go for the monopole stacking here. So in that case, we need to consider that sending the a single pulse there. Okay, so that's why we can say that it is about a monopole. Sending the single pulse, when it reaches to the target, so we will get the echo. Okay. So now through that particular pulse, whichever the echo signal we are receiving, okay, so then through that particular echo signal we can find out what will be the location of the target. But in general case, we are not relying on a single pulse to identify the location of the target. So in most of the cases what happens, so we are interested in finding out the what will be the position of the target through the multiple pulses. Okay, instead of a single pulse, we are sending the multiple pulses, and we need to find out the what will be the location of the target. And then through that we will measure the angle. Okay, so angle measurement is to be done instead of a single pulse. Okay, we can say that it is about, we say that is about a single pulse to be sent. So instead of that we can send the a multiple pulse. Okay, this one is about a multiple. Single pulse means what? This one, through the single pulse tracking we say it is about a single pulse. But if you consider that in a practical case, there will be the multiple pulses to be sent, and through that we can do the measurement. And then that will be useful for identifying the what will be the angle here. Okay, means we can say that in another way azimuth and elevation. So we can, or we can say that the angular information of the target. So now we are not saying right now what will be the range. We are just saying that what will be the angular information of the target. And then if we are using a single pulse, so in that case probability of identifying the given particular location or probability of detecting that particular target is low. Accuracy in that case, in terms of the accuracy, it will be low. If you use a multiple pulses, the probability of detecting a target or probability of locating the target, in which case the accuracy will be a more. So that's why we can consider that instead of a single pulse, we consider that a multiple pulse. But again, there are some drawbacks. Okay, when we can talk about the single pulse as well as the multiple pulse. Okay, so we can say that already we have said that that drawbacks are nothing but mostly in terms of a noise, and that we are getting we are getting a echo from a nearby target. Okay, that clutter will occur there, and because of that, whichever the multiple pulses we are sending, so somewhere we are getting the pulse that received or echo signal we have received, that received signal have the degraded value. So if we supposed to consider that a single pulse, so we are getting only that particular single pulse, so there will be the changes in only what degradation in terms of what we say that in terms of amplitude. Okay, so mostly if we consider that for the measurement, so amplitude should not be affected. Okay, whatever the we are sending the signal, okay, whether we consider that a single beam tracking or we can say that a monopole there. So in that case, so accuracy of the given pulse, it should not be affected by the amplitude fluctuation. Okay, so whether we are getting that given echo, target echo, and their amplitude of the given particular target will be fluctuating. Okay, because the target is moving. So it should not affect our measurement there. So we need to identify perfectly what is the location of the target. So that's why we can say that a monopole tracking that will be useful here to measure the angle here. So now we can consider that what will be the amplitude measurement here. Okay, just like we are just comparing the amplitude, or we earlier we say that we are measuring the difference in the angle. Okay, so likewise we have these two beam there. So we are just finding out the what will be the bore site and a target location. So instead of that here, so we consider that a a monopoles antenna pattern. Okay, so we say that we have a tracking radar, so it has the antenna. Okay, so that whatever the single pulse echo we are receiving from the target, and that single echo pulse we need to compare the amplitude of that echo pulse. Okay, so instead of saying a multiple pulses, so single pulse is sending and we are just measuring the echo of this one. So in that case we can measure the angle, and that measurement we just consider here in terms of a amplitude. So that's why we can say that a amplitude comparison of a monopulse, or what we can say that we are just comparing the amplitude of the given particular monopole there. So we just compare this, and then through this comparing, so we are getting a multiple what you can say that beam pattern. Okay, because we are just sending the pulse, we are getting the echo, so we need to find out the what will be the beam pattern formula. So we will get the various beams, and that beams we say that they have some squint angle related to the target there. Okay, and then we need to use this particular monopulse for tracking the radar. So right now I suppose to consider that a monopulse antenna pattern. So this is about a radiation pattern of a monopulse. Okay, so okay, now this is about a radiation pattern. So for example, we consider that we are getting the two squinted antenna beams. Okay, squinted means what? It has a squint angle of a theta now. Okay, with a small variation in the beam position. Okay, so at the from the axis to axis. Okay, so this is about axis to axis. That is about the angle. So we can say that in that case the squint angle will be a theta now. Okay, so that is about the variation. Or in another way, we can measure that this one is about in terms of what we can say that a polar coordinate, and if supposed to be we just finding out the amplitude in terms of a rectangular coordinate. In that case, radiation pattern will be L-equal. Because we have a two beam pattern, so two beam patterns will be L-equal. Okay. So in that case, so variation will be, that will be the angle, okay, covered by this uh, particular antenna, that will be of a theta. Okay. So in that case, these are the two beams. Okay, these are the two beams here. And if I suppose to consider these two beams, and if I add this two beam here, these are the two squinted beams. Squint angle means what? Difference between the radiation pattern. This is about a axis here. So another we have the axis. So in that case, the difference between these two axes is nothing but a squint angle. Okay. So now this has a squint angle of a, you can say that these are the two beams, and then I suppose to consider that adding these two beams here. Okay, so in that case, summation of these two particular beams. So we are getting the radiation pattern will be a likewise. So in that case, so variation of this angle will be a theta, and this one will be just like we are just summing this two beam pattern. And in the case of a rectangular one, rectangular coordinate system, so that beam will be squinted likewise. Okay, this one will be the adding. Now, if I consider that the radiation pattern of this two beam and this two beam, instead of summing here, if I differentiating this two beam, so in that case, differentiation of this particular beam, so we are getting the radiation pattern will be likewise. Okay, so these are nothing but the differentiation of the beam. Okay, so this one we can say that it is. In that case, we have the radiation pattern, and this one is about the difference, okay, theta. In the case of a uniform here, rectangular coordinate, or in terms of amplitude, we can consider that this one is about the radiation pattern of this particular two beam. So in that case, this one will be the a theta. Okay, so we can draw here. Okay, so that's about your radiation pattern. Okay, so likewise. So these are about the difference of this difference pattern of this two beam here. So in about the summation pattern of this particular two beam. And from this, we can find out the error signal. So error signal is nothing but what? A difference in the, what will be the angle here. So I suppose to find out the what will be the error signal here. So error signal in terms of what? A angle with respect to the, what will be the a bore side here. This one is about the error signal, and this one is about the error signal voltage. Okay, this one is about the error signal voltage. So through this bore side, okay, so we can find out the angle here for this particular two beams here. So in this case here, if you consider that in the case of a two beams here, so simple we just consider that from the monopole, so we just consider that overlapping of a antenna pattern with their beams. Okay, and that beams are just like, we can say that just slightly difference in the direction there. So means we can consider that supposed to be this one is about a target here, and we can say that for a given particular target, initially we send a pulse, we supposed to find out the target. Okay, and then we slightly shift that position of the beam there. Okay, so that's why we can say that in a different directions we can get the a two beam, and this two beams we are getting has a slight direction change. Okay, okay, small toward this direction here initially, and then this one, right? Okay, this one, right? Okay, slight change. Okay, so antenna is only the direction change. So that is called as what we can say that in between these two beams, that angle is called as a squint angle. Now we are just comparing this two beam. We are adding as well as a summation of these two beams. Here, this one is about the summation of the two beams. This one is about the, that's about the difference of these two beams. Okay, and through this we will find out the what will be the a squinted antenna pattern. Okay, so in that case, if you see that here is we are getting the squinted antenna pattern there. So while transmitting the signal, we can consider that summation pattern mostly. Okay, so we can consider that a two that we can say that even if we have a two beam patterns we consider. So generally, mostly a sum pattern is used for the transmission, but sum and difference pattern, both sum as well as the difference pattern, both are used at a reception there. So we can say that a signal received at the receiver, okay, signal received at the receiver, we are supposed to use a both the pattern that is about the sum and difference pattern. So that difference patterns, okay, so whatever the difference we are getting through the pattern, so this way through this particular difference we will get the what will be the error signal, okay, and that error signal is useful for the angle measurement. So this one we can consider that error signal voltage, so we will get the difference in the angle there, and that difference signal again is useful for comparing the phase of the different signals also. Okay, so that is about, you can say that error signal amplitude variation as well as a what you can say that is about the phase variation, and the sum signal that will provide that for the target detection as well as the range measurement there. So we consider that how to measure this, okay, how to consider this in this measurement carried out for this sum as well as the difference signal there. So we simply draw a diagram and that will measure the difference channel as well as the sum channel that will be useful for the transmission and reception for the tracking of a target. So generally just we consider that a monopulse here, and this one is about a monopulse tracking, and that monopulse tracking it will compare only the amplitude here. So we consider a diagram. So this one is about your transmit receive switch, about a transmit receive switch. Okay, so then mixer here, then about a mixer, then a IF amplifier, then amplitude detector. Okay, just like we are just detecting the what is the means comparing. Okay, detector amplitude detector means what? We are just comparing, and that amplitude compare the is useful for the range detection. So that will be given to the range. Okay, this one is given to the range. Now this transmit receive switch means just like a duplexer. So at the time of a transmitter, so we can transmit the signal. So this one is about a transmitter here. We can consider this one as a potty transmitter here, and then we have the a local oscillator we given to this mixer, and then another difference we have because we say that a sum signal and a difference signal. So mostly this is about a sum channel or a sum signal. Okay, then a mixer, then we have a IF amplifier here, then after this IF amplifier we use the phase sensitive information, so that's why we can consider that a phase sensitive detector. That is given here, and then phase sensitive detector that will provide the what will be the error here. Okay, so that is about a angle error. Okay, so now we say that this one is about a sum channel, this one is about what you can say that a difference channel. Now we need a antenna feed here. Okay, so from this a transmitter receiver feed we supposed to use a junction. Okay, we can consider that from the transmitter receiver we supposed to use a hybrid junction. So this one is about your hybrid junction. Hybrid junction means what? A magic tip. Okay, this one is about hybrid junction. And for this hybrid junction, so we get a signal to this hybrid junction that is about the summation signal. Okay, that's what we can say, that's about a summation. And from this, okay, the one signal is goes to this mixer, this one. And that signal is nothing but what we can say that is about a different signal. Okay, this one is about a different signal. And then for this particular switch, hybrid switch, we can give this to the antenna. Okay, so I suppose to draw it is about nearly one. This one is about a hybrid switch here. Okay, so we say that we have the antenna now. Antenna position is likewise. This one is about the antenna position. This one is about the antenna here. Okay, so this one is about your antenna. Okay, and that antenna is antenna from this we can supposed to be used for both. No need to use a direction here. This one is about the antenna position now. And here from this transmitter feed we supposed to give the signal here. And that signal even I can write here. And that is nothing but what? A summation signal. Yeah. Okay, so this one is about a summation signal. And this one is about the difference. Now these are about the antenna. Okay, so we can consider the two signals here. Okay, so that we will get the two squinted beams. Okay, these are about the two antenna here. Okay, so means we send that a two signal to be transmitted. Okay, this two signal to be transmitted through this, and this two signal through this hybrid junction. Hybrid junction means what? It is just like a T1. Okay, and that T will see this hybrid junction. So one at the time of a transmission, this one is the act as a duplexer. So only this TR switch will be on at a time of transmission. So signal will reach to the hybrid junction, and then signal will be divided in this two port here. No output will be there. Signal will be divided in this particular two port, and then we will get the output. Now, at the time of receiving, these two antenna are receiving this signal. Okay, at the time of transmitting, signal will be divided equally here in the two signal there, and it will be transmitted. Then at the time of receiving, the signals will be summed here. Okay, at the time of receiving, signal will be summed here, and then that summation signal will be transmitted. Okay, okay, this one. So summation signal will reach to the receiver. So at the time of this receiving, the TR switch will be act as a duplexer there, and it will only receiving. So your signal will be received by the mixer. Then a IF amplifier. Okay, comparing. Then it will detect the what will be the amplitude here. And from this amplitude, we can find out what will be the range of this particular object or a target. Now, then in another case, we have another signal that is about a different signal. Okay, at the time, and because this different signal we are getting from these two beams. Okay, the two antenna, these two signals, and the difference of these two signals we are getting in mixer, then IF amplifier. But we need to find out what will be the phase sensitive information. So what is the squint time? Okay, so that's why noise sensitive detector. So we'll get the error signal here because from the two beam we need to find out so what will be the error here. Okay, so now we consider that across this particular hybrid junction, okay, at this particular hybrid junction, this hybrid junction is useful for transmitting the two signals as well as it will be useful for receiving these two signals. Okay, so at the case of a two signal, okay, so this even if you are not able to see here clearly, so I'll just redraw the antenna again. This one. Okay. So now this one is about your antenna. Okay. So we can consider that these are nothing but that. Means two signals we are getting. At the time of a transmission, two signals will be transmitted. So the transmitter will be active. And at the time of receiving, okay, at the time of receiving, the two signals will come to the hybrid junction. then this hybrid junction will act as that hybrid junction will provide the two output. One is about the summation output, another will be the difference output. Okay, and then this summation as well as the difference signal here, as we have said that whatever the information we are getting from the sum channel, that is about the amplitude. Okay, as we have seen, so we are getting a information from the sum channel, that is nothing but what we can say that amplitude. But information we are getting from the difference here, that will be phase as well as the amplitude. So okay, so we are interested in what these two information, that is sum and difference channel, and that are the input to what a phase sensitive detector here, and then it will compare this particular two signal in terms of what will be the frequency and all, and these two signals are nothing but what, from the sum channel as well as from the difference channel. So here it will provide her the what will be the changes in the phase here, and then it will provide you the phase sensitive detector. It will provide you what will be the angle error in error signal. Okay, so we'll get the angle error signal, and that angle's error signal consists of what, a target angle theta t, and as well as the what will be the difference with respect to the theta 0. So here we can say that if theta t, okay, plus or minus, okay, so that we will see later. Okay, so if that theta t minus theta 0, so based on that whether it will be a positive or a negative side. Okay, so either your target position right side or a left side likewise. So you can say that from this particular sign of that particular output, so we can find out what will be the direction of the target, means toward the bore side, in which particular direction that target is present. So bore side can be find out. Okay, through this particular. But in the case of amplitude, so we are getting the signal here, that is in terms of amplitude. So that amplitude of the particular signal, that is about a sum as well as the difference. If we compare, that is about a, we can say that for this sum channel, we can say that signal will be what, as cos of omega t. Okay, so that is about what will be the angle. But in the case of a difference channel, suppose I consider that it has a two component. One is about what, a positive difference or a negative difference. So means difference signal will be either consist of a positive, means we can say that AD cos of omega t, or minus AD cos of omega t. That plus AD or a minus AD, that will be depend upon the what will be the bore side, okay, of the target there. If we consider that the target, okay, difference, we can consider that toward the bore side or the which direction, so that will be given through this error signal also. Okay, so similarly we can find out through the comparison of the amplitude, so difference in the signal in terms of phase, okay, as well as in terms of a what will be the amplitude also. Okay, so that's all about what you can say that a monopole stacking. But if you consider that the case of what you can say that a hybrid junction, so hybrid junction is just like a looks like a what you can say, we have earlier we have seen that a magic T there, so it just looks like a magic T. So in that case, if you consider that a magic T, it has a component of what, electric field as well as the magnetic field here. Okay, this is about E junction, and this is nothing but a S junction. Okay, so this is about a magic T. So now I consider that a magic T here. For example, this port, okay, I say that 1 and 2. And suppose I am providing the input from this port, okay, in this case of magic T. If I provide the input from this port here, so output will be available at port 1 and port 2 with same, output will be divided and your phase will be the same. But if you consider that the input from this end, so output will be equally divided in port 1 and port 2. but there will be the out of phase, but there won't be any no output at this particular port. So this one I suppose would say 3 and 4. So if input is here, no output at 4. If input is here, no output at 3. But in the case of hybrid junction, so we are providing the input at 1 and 2. So in that case, we are getting the difference here and we are getting the summation, because that output will be 180-degree out of phase if we provide here. So this port is act as a difference signal port, and this port will be act as a summation. So that's all about what we can say that a monopulse tracking, so in which a hybrid junction needs to be used. With this, stop here. So thank you all.